Hi, welcome to today's video. In the previous video, we looked at the official Turing PI case. And in this video, we are gonna assemble it. So, let's get started. I'm Garrett, and this is TimmerTech. Hi. So, today we're gonna assemble the Turing PI case and install the Turing PI board. Now, before we get started, here's a little household trick. When you are installing a hardware in a computer case, for cable management, you can use zip ties and all kinds of other things. However, I recommend using something as simple as some rubber bands. They're quite handy, so my advice, keep one or two on hand when you're installing the Turing PI board, and you will see what I'm going to use them for. So, let's get started. Hi. So, a little safety warning when working on computer hardware. Always make sure you're grounded, that the static electricity has left your body. You can use a faucet in the kitchen to ground yourself. But here is something that a lot of people forget about. Your clothes do matter. So the more synthetic fibers in your clothing, the easier it generates static electricity. Natural fibers are less prone to generate static electricity, which lowers the chance of you damaging your hardware. So wool, cotton, linen, they're good, lowest amount of static electricity, but synthetic like polyester, that will actually increase. So even a blended vest with 80% cotton and 20% polyester like this one, that can generate static electricity when in contact with a shirt. So my advice when working on computer hardware, 100% cotton t-shirt. That's it for the safety warning. Just remember, always be careful. So let's get started in assembling our case and Turing PI. We got a case, we got a Turing PI, let's get started. So I made some photos for especially these cables for the power button to make sure that they're easy to connect. They go all the way here. I will show it more in detail later. Now, before we get started on putting the Turing PI in, I'm actually gonna put in a additional SSD drive, which I'm gonna use for backup. And because of the cables, it's wise to install the drive first. So let's get started with that one. I got for the backups a 1 TB Samsung 870 Evo 2.5. That's 1 TB of SSD storage. And of course, what we get for that is a SATA cable and the SATA power cable that comes with the Turing PI, which in this case connects to the PI adapter here. Let's get this one installed. In order to get this easily installed, we need to remove the top and the bottom so that we can easily access the brackets from both sides. Now, before I'm going to install it, I'm going to quickly look where the connector is. So this is the back because of the IO shield, right? Which means that the Turing PI with the ports here goes literally in like this. And here are the two SATA ports for node 3. This is SATA 1, this is SATA 2. So based on that, logic would say that connecting the cable the drive comes here like this. So connecting it this way and then over here to the SATA ports, which means I am gonna put in the ports on this side. It does not really matter which way you put it. I'm just gonna put it with the top towards it. I do have a cable with a 90 degrees connector port on it, which allows me to put the connector in like this, and then the cable should run perfectly to this area where the SATA port is going to be. Now let's run through our screws. These are the screws that come with the Turing PI, so we got a bunch of ones. I'm thinking, as far as I can tell, these long black screws are probably for the fan. Don't know what these are for. And we got some standard screws, which we can use for the board and for the drive. So, and we got 3 larger ones. Oh, I'm guessing that these 2 tiny black screws, I'm thinking they are for the replacement of the I/O shield. And the rest, well, we're probably gonna figure it out. Now, before we're gonna continue, I'm gonna show you guys something about the case that I learned. So this connector is the connector for the front USB. Now the connector comes with an additional cable attached. After looking through the Turing PI community, this header is not used. So this is just a standard cable. Now to ensure that this does not go moving around in the case, I am tucking the cable. Let's see. I'm tucking it between the cables. And as I said in the intro, a simple rubber band. So it's a very, very simple trick. To keep everything nice and secure. And one more go. Twist it around and voila. Well, maybe not that pretty, but definitely practical. So before I should get started, because I do not, because I'm not going to use a flex PSU, I'm assuming the cable for the flex PSU goes either here at the top. That's the only way that makes sense. It can go at the bottom hole here too. Right now what I'm gonna do is I'm just gonna push it through the bottom one to get it out of the way. So, now flip this up. This one too. And let's get this drive installed. Now I'm gonna go with, I can buy the top or all the way till the back. Let's see what is the most convenient. So based on the space, what I'm currently thinking about is if I put a drive in, I do not want all the cables to block each other. So I'm gonna put it in the holes closest to the wall. That way the USB-C front header cable has enough room to move around. That has to move with a twist actually to around here. So that's gonna be a hard one without breaking everything. It will be under strain, under stress. It should roughly go about here. So yeah, it should roughly go here somewhere. And by putting it all the way to the wall where my index finger is here, I'm giving enough space for the cables of the SSD drive not to interfere with each other. Now, getting this in is always tricky because it's so close to the edge. So it should go here. So it does have, let's see this like this. So based off the orientation of the board, the ATX24 pin connector will be around here on this side. As you can see, this is the IO shield and this is on the opposite side. Now, it does fit with the shortest one. I will have to move. I have to turn the drive. I forgot that the 90 degree connector goes down on the drive. And down means, as you can see, this way. So that was not really the best choice. Hey, if you are enjoying this video, don't forget to hit that like button. It really helps the channel grow. And if you haven't already, subscribe and turn on notifications so you never miss out on future content. All right, let's get back to it. Let's get to driving. I'm now holding the connector, the SATA connector with my thumb, so there will not be too much strain on the connector because of changing the cable. Not happy with that. No. Okay, so do not do this. Do not put it to the bottom square one. It looks like, thankfully, I'm holding the connector down with my thumb so it doesn't break anything. But based on the sizing, we're gonna put it to the top one. Normally it would not go there because this is the mount bracket where the flex PSU would go. So normally you would not have room for that, but yes. Wow, perfect. Perfect. Now this power connector has to go all the way through the bottom. Well, actually, I am now a little bit worried. I am now very worried. No, this is not gonna work. This is not gonna work. There is not enough. I think it is too short to go. Well, let's just measure it a little bit. This goes here, roughly. And the Pico goes with the clip here. So the header for the connector goes to the inside. So it faces this way. So that means that it's all the way here. And well, it is possible, but it might be under some strain. Better be safe than sorry. I'm moving the drive. The problem I'm now dealing with is this black header cable, and there is a little pin here to ensure that it goes outside in one way, so it has to go with a twist. Actually it will be under quite some stress actually. So I'm now thinking, what is the best approach? I am gonna put the drive the other way around and use a different connector. Also, this is one of the benefits of using a rubber band. They're so easy to untie. All done. Now, if you want to install 3 drives, I'm guessing you have no other choice but to have all those wires together and then have the nearest drive use the first connector. But I do not like the stress and strain on this cable. So if we simply go with the furthest connector, I'm gonna be good. And then I can run the cable actually behind the drive here, all the way at the bottom through the square hole. So yeah. And again, as you can see here, these are the connector pins. Of course, do not touch them. You do not want any skin oil on that. And even if your hands are dry, human skin has oils in there. Okay, now drive's gonna be like this because of the 90 connector. I could have gotten another cable, but I just want to use this cable. Then we're gonna put in the drive like this. cable at the wall. Yeah. And then this cable can actually go nicely run like this, run, let's see, I'm gonna show this. So the cable is gonna run here and it's gonna run nicely to the SATA connector, to its SATA port. So yeah. Well, 2 free tries. First try's a charm, as they say. Still gonna use, am I still gonna use the closest? Well, in this case, I am, as looking about the space, I am putting the drive all the way at the back. That does mean that I am out of one connector, but hey, I don't see that as a problem. Don't worry, there is enough room between the wall and the drive for that cable I'm putting there, so. Nice. Finally, how I wanted it. So, let's see if I can show this. Okay, so we got the drive upside down, 90-degree connector. It runs nice flat this side. The power connector here runs behind the drive, and that runs all the way to the square hole. Here's the other one, and this one is gonna connect to the Pico. So, drive installed. Now, we are left with the board. Hey, if you are enjoying this video, don't forget to hit that like button. It really helps the channel grow. And if you haven't already, subscribe and turn on notifications so you never miss out on future content. Alright, let's get back to it. So now we need to wire everything up. Now, here's a little trick. It would be easy to put this one in because, hey, that just clicks in and there is actually here a black header where it goes in, right? However, that would make it more difficult to put in the power and the LED. So what we're gonna do is we're gonna connect these two first. So they are attached. You can break the wires, strip them loose. Not a problem. Now here's the thing. This is really hard to see. We have red, white, green, black. And the red and white is the LED for the power button. And the black and green is the power soft switch. Now, here is how you do it. You orientate the case with the button towards you and the back with the I/O shield away from you. Then you look straight in front of you. You have F panel 1 and F USB 3 node 4. That's where the USB goes. Now, of the F panel 1, you got 2 rows of 5 pins. 1 pin is missing. So the front row is 5 pins left to right, back row left to right, 4 pins. The 5th one on the second row, pin 10, is missing. Also, what is really hard to show on the camera is that when you look very close at these connectors, at the side where it doesn't have text, but where you see 2 metal pins, you will see that the colored wire also has a tiny triangle. Now, I put it into a photo. The most left pin on the front row, that's the side towards the power button, also has a triangle. So, just to make it clear, the power LED goes on the first row and the power switch goes on the second row behind it. The power LED goes on the 2 left pins on pin 1 and 2. And the power switch goes on the second row on the 2 far right pins. And the black wire is directly next to the pin that is missing. So the red wire on the front row for the power LED goes on the left because there's a little triangle. And the black wire of the power switch goes next to the pin that is missing. So, connected. Now comes the hard part. We need to twist this USB cable in such a way that it will go in to the board without damaging anything. Put your fingers under the board and then press it down. Do not exert power with such a cable under tension on the board. Now actually it looks like I'm just checking to make sure that the cable doesn't want to leave on this side and that the cable wants to move out of its socket like this. So it should be flat and we do not want it hanging in the socket like this because of the tension of that cable. And it can only go in one way, so they should really make this cable longer. It looks like it is straight connected. I'm just gonna make sure. Okay. Now, what's left is SATA, and that goes in SATA 1 in my case. And again, your fingers under there while you press down the cable. Just hold the edge of the board and make sure that you press down straight Click. Okay. Now what we're left with is the power. So in this case, I'm first gently, let's see how this one goes in. This one goes in with the metal exposed ones to the top. Using my nails to press it down. And it's in. Now comes the final two parts. This one goes here to the big hole. So I have to secure this one. Let's, oh, that was very stupid of me. Do not drop the cable. I'm holding it with 4 fingers. I'm holding the edge of the board to gently press down the connector and to make sure it doesn't break anything. I don't think it's fully in. Yeah. Oh, this requires click. This requires more force than I thought. How much do we have? I'm gonna put this under here. Now, on the Pico connector, there is actually a ring, and you can simply remove it. And I'm guessing the ring goes on the outside, so just through the hole. And secured. Not happy with that. So what I'm gonna do, I am gonna use the tension of this cable. Rubber band to the rescue. The reason why I'm using rubber bands is that, yes, I am a fan of tie wraps on zip ties. However, for me, that's more the permanent solution when I'm happy with everything. And cutting everything off and doing new ones, yes, absolutely not a problem. However, it's, let's see if this works. Cool. The reason is I do want to avoid that the cables are touching the heat sinks. So, washer. Okay. Now, gently flip it over. And there you get to see my NVMe drives. Power button is here, so the missing corner goes there too. So, we're ready to test it. Let's hope I didn't make any mistake. The Pico external adapter. Well, we do see a nice green light. We do see the orange light here booting up the BMC. Now I can turn on the nodes. My nodes are currently not loaded with any OS, which I'm going to show you how to flash nodes in a following episode. I can try it, however, to see if my power button connection is correct. So this should turn on the nodes. And there you have it. Now I'm quickly turning it off because there's nothing loaded on there. But yeah, press 1, nodes boot up, immediately press again, nodes. Now I didn't check, by the way, if the LED is working. Yes, nice blue light. Everything as we wanted. A satisfying click. And there you have it. One nice assembled Turing PI case. So, thank you for watching and see you guys in the next episode. I'm Garrett and this is Timmertech.